The possibility of human survival outside Earth is constrained by the harsh environmental conditions of other celestial bodies. This report examines how long humans could survive on each of the 9 planets, the Sun, stars, space, and the Moon, considering factors such as temperature, atmosphere, radiation, gravity, and available resources. 1. Mercury. Environmental conditions. Mercury is the closest planet to the Sun, with extreme temperature fluctuations, ranging from -173 degrees Celsius at night to 427 degrees Celsius during the day. It has no atmosphere to shield from the Sun's radiation. Survival duration. Without protective equipment, humans would not survive even a minute on Mercury. The lack of an atmosphere means there's no oxygen, and the temperature extremes would quickly lead to fatal consequences. In a specially designed habitat with radiation shielding and life support systems, humans might be able to survive indefinitely, though extreme heat would make it difficult to sustain a permanent colony. 2. Venus. Environmental conditions. Venus has a thick, toxic atmosphere made mostly of carbon dioxide with clouds of sulfuric acid. Surface temperatures average around 465 degrees Celsius, and atmospheric pressure is 92 times greater than Earth's. Survival duration. Without protection, humans could not survive on Venus at all. The high temperature, crushing atmospheric pressure, and toxic atmosphere would kill any human within minutes. With a highly advanced, pressure-resistant spacecraft or floating habitat in the upper atmosphere, where conditions are less extreme, humans might survive for a limited period. 3. Earth. Environmental conditions. Earth is the only planet known to support life. It has a breathable atmosphere, liquid water, moderate temperatures, and a stable climate. Survival duration. Humans can survive indefinitely on Earth, assuming they have access to food, water, and medical care. However, factors like climate change, resource depletion, and natural disasters may challenge long-term survival if these issues are not addressed. 4. Mars. Environmental conditions. Mars has a thin atmosphere, mostly composed of carbon dioxide, with surface temperatures averaging -60 degrees Celsius. It also has radiation from the Sun and cosmic rays due to the thin atmosphere. Survival duration. Humans cannot survive on the surface of Mars without life support systems. In a habitat with oxygen supplies, temperature regulation, and radiation shielding, humans could survive for an extended period, potentially indefinitely if resources such as food and water are sustainable. Current missions are focused on building long-term habitats to explore the potential for colonization. 5. Jupiter. Environmental conditions. Jupiter is a gas giant with no solid surface. Its atmosphere is composed of hydrogen and helium, with high radiation levels and extreme storm activity, including the Great Red Spot. Temperatures in its upper atmosphere are about -145 degrees Celsius. Survival duration. Without any surface and with extremely hostile radiation, Jupiter is not suitable for human survival. The best potential for survival might be in space, stations orbiting the planet, or on its moons, like Europa, which might harbor subsurface water. In such stations, survival could be extended as long as life support systems remain intact. 6. Saturn. Environmental conditions. Saturn is another gas giant with an atmosphere of hydrogen, helium, and methane. It has extreme temperatures of around -178 degrees Celsius and a lack of a solid surface. Survival duration. Like Jupiter, Saturn itself is uninhabitable. However, human survival may be possible on its moons, such as Titan, which has an atmosphere and liquid lakes, albeit methane-based. On Saturn's moons, survival would depend on creating self-sustaining colonies with life support systems that regulate temperature and provide resources. 7. Uranus. Environmental conditions. Uranus is an ice giant with a very cold atmosphere made of hydrogen, helium, and methane. Its surface temperature averages around -224 degrees Celsius. Survival duration. Without any solid surface and with frigid temperatures, Uranus is not suitable for human life. Survival would require floating habitats or stations, and humans could survive only in controlled environments with adequate protection against the cold, radiation, and lack of oxygen. 8. Neptune. Environmental conditions. Neptune like Uranus, is an ice giant with extremely cold temperatures, averaging around -218 degrees Celsius, and an atmosphere made of hydrogen, helium, and methane. Survival duration. Similar to Uranus, Neptune itself is uninhabitable. Any potential human colonies would need to be placed in orbit or on one of its moons, requiring advanced technologies to support life in these extreme conditions. 9. Pluto dwarf planet. Environmental conditions. Pluto is located in the far reaches of the solar system, with surface temperatures averaging around -225 degrees Celsius. It has a thin atmosphere composed of nitrogen, methane, and carbon monoxide, which freezes in cold temperatures. Survival duration. Survival on Pluto is impossible without significant technological support. Humans could survive in specially constructed habitats, but the distance from the sun and the harsh cold would make it a very challenging environment for long-term habitation. Resources such as water would need to be transported or extracted from local sources, assuming any can be found. 10. The Sun. Environmental conditions. The Sun is an immense ball of burning gas, with surface temperatures around 500 degrees Celsius. Its core reaches temperatures of around 15 million C, and the Sun emits intense radiation that would be fatal to humans without extreme shielding. Survival duration. Humans cannot survive near or on the Sun. Any attempt to approach the Sun would result in immediate destruction due to the extreme heat and radiation. The Sun's proximity is only useful for harnessing solar energy through spacecraft and solar panels in space, not for habitation. 11. Stars. Environmental conditions. Stars, including our Sun, are massive bodies of hot, ionized gases. Their surfaces can reach temperatures in the thousands to millions of degrees Celsius, making them inhospitable to any form of life. Survival duration. Survival near a star is impossible due to the intense heat, radiation, and lack of a solid surface. Humans could only survive by remaining in spacecraft or space stations far from the star, utilizing advanced technology to avoid harmful radiation. 12. Outer space. Environmental conditions. Outer space is a vacuum, meaning it contains no breathable air, extreme temperature variations, and constant exposure to cosmic radiation. Space itself offers no support for human life. Survival duration. Without protection, humans can survive only for a few seconds in outer space. A properly designed spacesuit or spacecraft is required for survival, providing oxygen, temperature regulation, and protection from radiation. In these conditions, humans could survive for months or even years, depending on the efficiency of the life support system. 13. The Moon. Environmental conditions. The Moon has no atmosphere and experiences extreme temperature variations, ranging from -173 degrees Celsius at night to 127 degrees Celsius during the day. It is also subject to solar radiation. Survival duration. Humans cannot survive on the surface of the Moon without protective equipment and habitats. In habitats with life support systems and radiation shielding, humans could survive indefinitely, assuming sustainable food, water, and energy resources are available. The Moon's lack of atmosphere and water makes long-term survival challenging without advanced technology. Conclusion. Human survival on other planets, stars, and in space depends on the availability of life support systems, protection from extreme temperatures, radiation, and the necessity of creating self-sustaining habitats. In environments like the Moon and Mars, long-term survival is possible with the right technology. On gas giants like Jupiter and Saturn, or on the Sun and stars, survival is not possible without extreme technological advancements, and even then, it would be extremely limited or impractical. The future of human exploration will depend on overcoming these challenges and advancing our space technology to ensure safe and sustainable living beyond Earth.